The laser printer works by having a main brains called the which is located on the right side, press return, of the printer along the right face near the rear in the center as far as vertical position, and is about 5 inches wide, press return. Press return. By 6 inches tall. It also has a power supply located in the bottom of the printer made up of multiple PCBs taking up, press return, most of the bottom of the printer's surface area, but they are not very tall, maybe 3/4 of an inch tall, and press return, 14 inches wide by 14 inches long, press semicolon. This power supply has a high voltage supply used for the laser systems and for, press return, charging up various rollers and fusing ink powders with electrical charge so that the powders stick to the rollers, press return, and the transfer belts and the papers, etc. Everything to do with controlling the fusion ink powders deals with, press return, charging the particles and having them suck to other charged surfaces via magnetism. Press semicolon. In fact, the laser changes the, press return, surface charge of the imaging drum in the spots that it hits on that drum, because its photons of light energy, press return, make a less negative charge. And the highly negative charged particles are drawn to that less negative charge. Press semicolon. Press return. And so they stick immediately. And in this way, a pass of each of the colors, press space, of, are overlaid onto one another to, press return, form the image, one at a time, from each of the 3 color rollers, and from the black color roller. And they, press return, are applied with 600 dots per inch precision. Press semicolon. After applying the image to the imaging drum, that drum passes the image, press return, onto an image transfer belt, which then passes the image onto the sheet of paper. Press semicolon. Press Ctrl S. The power supply also has, press return, a standard lower voltage supply board that creates 24 volt, 5 volt, and 3.3 volt, and sends those off via cabling to the, press return, main brains DC controller PCB, which runs the DC controller PCB, and the DC controller PCB distributes that, press return, cabling throughout the system, serving as the brains of the power grid. Press semicolon. Press Ctrl S. The 24 volts supply all of the solenoids and motors in the device. Press return. Press semicolon. There are only 4 or 5 motors because they use gears and shafts and reducing gears. Press return. To enable a single motor to power many different things at the same time. And this saves money on buying many more motors. Press return. To power each individual thing, as they are trying to maximize profit margins. Press semicolon. It is also interesting to note, press return, that nearly the entire thing is constructed of plastic of various sorts. To save money. Press semicolon. It is impressive to see, press return, all plastic gears and cams and bushings and rollers and casing elements which are strong enough to hold up. Press semicolon. You, press return, will see ribbing all over the flat plastic, designed to make it stronger and not bend. Bend. Just like I added ribbing, press return, to the mobile mechanic pop-up tent fiberglass wheels to make it stronger and not bend. Press semicolon. Press Ctrl S. There are about 5 sensors, press return, in the whole machine. Press colon. One senses the density of the fuser ink, comma. One senses how full the fuser ink waste carrier container, press return, has become, comma. One senses the paper has been inserted into the tray, comma. One senses the paper has reached the 1.5 inch mark, press return, during its travel into the printer, comma. One senses the paper has reached the fuser area, which is the part that melts, press return, the fuser ink powder into the paper. Press semicolon. One reads the ink cartridge magnetic strip for information about it. Press semicolon. And press return. There are a decent handful more, but those are the main ones that matter. Press semicolon. Press Ctrl S. The printer starts by rolling various rollers. Press return. Moving its laser carriage to the home position switch and then moving it out to its setup position, comma. It warms, press return. The laser up, comma. It uses the same laser for the scanner and the printing, by the way, which is amazing. Press semicolon. It runs tests, press return. To verify no paper is in the machine, and if it is, it automatically says there is a paper jam. Press semicolon. It also primes, press return, the various rollers and imaging drum and fuser ink, dust with the electrical charge to prep all of that stuff for the imaging process. Press return. Press semicolon. Then once all of that is ready, it triggers a solenoid using a 24-volt power switch to turn it on. Press return. Using a MOSFET. And that solenoid somehow engages a clutch, which supposedly removes a stop from the pickup roller assembly. Press return. Which allows the pickup roller to start turning because it is somehow coupled to the gear system. Press return. And so the pickup roller is allowed to make one full revolution, causing its rubber gripping D-shaped roller, press return, pad to grip the topmost paper and slide that forward, and the other papers get shed off from the, press Ctrl F, pad, press Ctrl C. Press Ctrl C. Shoved. By the, paste it. Press space. Press return. Press delete. Press space. Press semicolon. And so just the one paper can make it through. And the printer reads for that paper to pass. Press return. A registration sensor, which verifies to the printer that it made it through. Press semicolon. If that sensor were to see a paper before, press return, the appointed time that the pickup roller should have sent it through by, comma, then the printer will think it's a jam. Press return. Paper. Press semicolon. If the paper does not make it in time to that first registration sensor, comma, the printer will think it's a paper jam. Press return. Press space. Press hyphen. Press space. And that was my problem. Press space. Press hyphen. Press space. My pickup roller stopped engaging and stopped working entirely. And so, press return. The printer would always say there's a jam because it was never getting a paper to the registration sensor. Press return. And so it thought a jam must be occurring somehow. Like perhaps too many papers were trying to get through. Press return. Because you overloaded the paper tray. Press semicolon. Press Ctrl S. So after the 1.5 inch travel to that registration sensor, comma, feeder rollers, press return, take over from there and carry the paper through and around the midpoint the transfer belt applies the fuser, press return, powder, dust that it got from the imaging drum onto the paper media. And the transfer is made because of the different electrical charges. Press return. On the paper potential, comma, imaging belt potential, comma, and fuser powder dust potential. And basically, press return. The fuser dust particles are so negatively charged that anything with even a neutral charge they will cling to for dear life. Press return. And so they cling to the paper really well. Press semicolon. And the paper continues to travel along from there. Press return. Till it gets to the fuser heater, which is positively charged. And that heater melts the fusing dust particles, press return, into the paper, while also pressing them magnetically into the paper by virtue of the fact that the heater itself, press delete, press return, is positively charged. Fuser dust particles are negatively charged. Negatively. And so these like charges repel each other. Press return. one pushing the other away, and pushing the particles deeper against the paper, flattening them as they are baked. Press return. Press semicolon. Press Ctrl S. And following that, the paper travels up and then out the front of the printer. Press semicolon. Press Ctrl S. Every single panel on, press return. The sides, front, comma, rear, bottom, etc. are all removable with screws. And some have plastic tabs you have to be careful about. Press return. Press semicolon. The repair guide has detailed instructions for removing anything with these panels, and you, press return, can remove any part with detailed instructions on how to do that as well. Press semicolon. The repair manual also has a, press return, breakout blown up guide at the end showing every single bolt, spring, cam, roller, bushing, gear, connector, press return, motor, solenoid, etc. and how they all snap together, and the order in which they are put in. Press semicolon. You can buy replacement, press return, parts as complete assemblies or as individual parts for every single portion of the printer. Press return, including the laser, any gear, any bolt, any spring, bolt, the whole control panel, the control panel bezel, press return, the power supply, the main brains DC controller PCB, any motor, any sensor, any gear train assembly, press return, any PCB used for sensing or whatever, the whole automatic document feeder assembly at the top, open parentheses, ADF, close parentheses. Press return. That feeds paper as a copy machine, comma, etc. Press semicolon. So in other words, comma, this printer is meant to last for life, press return, and parts to be ordered as they wear out or get damaged or broken. And HP intends to support each model, press return, of their printers indefinitely, press semicolon. So you can buy parts at any time if anything goes wrong. And by reading, press return, the manual, you can gain clues and troubleshooting tips for how to try to find out what is wrong. Press semicolon. Now I press return. Undo. Press return. Being a master fabricator and electrical engineer, comma, would rather simply fabricate any broken part from scratch, press return, or repair the part itself using material science and sophisticated techniques and tools. Press semicolon. Press Ctrl S. This will avoid, press return, having to buy extremely overpriced replacement parts. Press semicolon. For small pieces of plastic weighing only a few ounces, comma, press return. They charge $40 plus shipping. Press semicolon. It is absolutely ridiculous. But it becomes that way because of such a low, press return, demand, because most people simply throw the whole printer away anytime something goes wrong, which is insane. Press return. But it is actually more economical than paying someone skilled enough to actually do the fix and paying for, press return, the insanely overpriced parts. Press semicolon. But for someone motivated to learn and save money, comma, it is a great opportunity, press return, to see unbelievable engineering and ingenuity on display, to dig into a machine like this, comma, locate the fault, press return, and do the repair, press semicolon. The experience is priceless, and all of the many things you can observe from the way they, press return, do the cable connectors, comma, the way they route the cable, comma, the way they organize the layout and structure of the machine, press return, comma, the excellent documentation they create, comma, the attention to detail, comma, the ways they save on cost, press return, by using cheap plastic for every imaginable thing, comma. It's all just a wonder to behold and a privilege, press return, to work on, press semicolon, press Ctrl S. Look up how to take off right door. Press return. Look up how to take off right gear assembly. Press return. Look up how to take off cover. From MainBrain's DC controller PCB, so that we can access it and look at it and study it. Press return. Gear. Press return. Visually inspect. Locate and inspect the pickup roller gear system and its solenoid and clutch system to interpret what it looks like and how it works, and what went wrong. If something physical went wrong, press space, press hyphen, press hyphen, backspace, comma. Then we should be able to identify damaged teeth or bent up stuff, or stuff that is no longer engaging properly. Press space, press hyphen, press space. And if this were the case, comma, we can set about to repair the damaged components or fabricate them fresh using mold making, possibly 3D printing, sculpting, etc. Press semicolon. Press return. If we do not identify anything physically wrong, comma, attempt to actuate the solenoid to see how it works, or if it is working at all. Press semicolon. I guess we can use batteries to create the 24 volts we need, wiring them in series. Press semicolon. We know the name of the connector from our notes and can locate that connector on the main PCB and connect our jumper pins to its 24 volts and ground to cause the solenoid to actuate. press semicolon. If nothing happens, comma, it might be a solenoid failure issue, and we can use a multimeter to test for continuity on the various lines. And we can also look up how to repair a solenoid, if that is something we need to do. If we deem the solenoid cannot be repaired, or would be impractical to repair, comma, look into replacing it by purchasing one for only $8. Or look into making one from scratch, which would probably be very rewarding. Press semicolon. Or possibly replace it with a stepper motor, which pulls from the 24-volt signal feed off the main controller board via a voltage divider, which tells the Arduino to switch on the stepper and move it however long the solenoid was moving to engage the pickup roller and get it turning for its full rotation. Press return. If that all is impractical and the gears are just too botched and it just looks too much of a mess to deal with, comma, simply cut free inspect both ends of the pickup roller our left side of the pickup roller to verify cut the pickup roller near its right side in half, which, press return, will disengage it from the right side gear assembly entirely. And then we can create a bushing to support the two cut halves and bridge their gap and keep them in proper alignment, comma, made of plastic of course, comma, and this can be supported against the rear facing wall press delete. Press backspace. Just behind the pickup roller shaft by using a plastic support beam system beam, press semicolon. From there, comma, we can just use a DC motor with a pulley and an Arduino to turn the pickup roller independently from the printer, 1 full rotation, and we will know the timing of when to do this based upon reading from the output pins of the 24-volt supply to the solenoid that triggers the normal clutch engagement of the pickup roller during a normal print job, and this signal being turned on will be read using a voltage divider. Press semicolon. The DC motor will be powered using the 24-volt line coming into the main board from the power supply, which we can splice off of and run wiring for our setup with from. Press semicolon. The 5-volt feed for the Arduino will also come from where the power supply sends a 5-volt line into the main board. Press semicolon. The 24-volt and 5-volt lines as they enter the main board are labeled clearly in some of the rearmost pages of the repair manual. Press semicolon. Also, the 24-volt supply to the solenoid that usually kicks off the pickup roller clutch engagement and will set our timing up, comma, is labeled in our notes and in the repair manual, and its location on the main board will be written with screen printing on the main board